And we're back. Last time I was trying to demo things, I got to debug and discovered I'd forgotten 1, the structure of ranges, and 2, that ranges weren't fully implemented. Then when I was starting to to put out another video, I realized I'd forgotten that the entry point had not moved, and I overwrote debug with a move command, and I called it quits without even bothering to push it out. So here we are. All that stuff is fixed. Debug has got a lot of new features, and let's show them off. So first thing, we'll just kind of go through my current test suite that I just kind of created. First thing is that it is case insensitive, so I can do D like that, same way. And it ignores spaces. So those are like the most minor things. There's technically a command buffer, maximum 63. I'm not going to type in 63 characters. That's very, very boring. Just believe me. So we'll do hex arithmetic. It's built in just like MS-DOS was. It shows the addition and the subtraction. Important note, absolutely everything in debug is in hexadecimal. If you don't know hexadecimal, learn it. Because learn it. It handles overflow. And wrap around. And all hex numbers, for example, are validated. Parameter count is validated mostly. I discovered that this, which should be an error, works. But on this one, I'm conflicted. I believe it should be an error based on a parity matter. I'm okay kind of with it working. If it added and subtracted all the numbers, that might be a little better. I think I'm going to fix it so that it's an error if you add more than 2 numbers, though. The next one we're going to look at is memory manipulation. Memory manipulation is actually kind of fun. So if we just hit D, because I've already dumped something, it starts out a little higher, but it should start at 2000 and dump out 16 rows at a time. We can do ranges in a couple of different ways now, either explicitly like so, or ranges are all specifiable with a limit. We can do memory editing. Now, some of my test suite has different memory addresses, and I'm going to use, I'm going to stay up in the 4000s because those are more or less memory safe for the debug application. Stuff starts to exist in the 2000s and 3000s. So let's dump out 4000. we don't really need to see all of it, so we'll just take a look there. I can edit it. Before I move on, if I just dump, it'll continue to dump things. So let's dump out 4,000 again, and we'll edit 4,000, and we'll just stick some stuff in it conveniently. Yeah. Now, in addition to just editing like so, we can let's do 4010 edit strings. After edit, we've got fill. Fill is as expected, and we can show it off pretty easily. Let's fill in all that 4,000 area with some zeros. Take a look again. Now we can do it with ranges. If we do 4,000, we limit F, and then AA and D 4,000 L20, 4,000 L20. We'll see that we've only filled in that first 16 byte or 15 byte range. Another nice trick is you can do patterns. So if instead I do L, let's do 1F to show it off, A, B, B, C, C. We see that it fills in pattern, repeating, which is kind of nice. Now let's take a bigger look at 4,000 so that we can show off moving. If we move 4,000 and limit that to 16, and then move that, we can move it down to let's say 4040. It'll just do a straight copy, and then we can do similar. We can do comparison now. If we compare 4,000 to 4040, but we'll want a limit there, so we do by 10. Actually, let's do 11, and we'll show off a difference. So we'll do 4040 and show us where they diverge at every location. If I were to say fill 4040 with AA, if I fill 4040 with AA and then compare 4,000 we'll see all the places where it differs, which are all the places where it's not an AA. Search also works. So we can search for patterns. If we search 3,000 to, not 3,000, we search 4,000 to 4040, AABB, we get all the locations where it comes up. If instead we were to search 4000 4040 for AA00, I'll only find it one time because it only exists down there at 41E. We can also, if we do, if we edit, I apologize, but typing on the Commodore 64 is even harder than generally typing on a QWERTY keyboard. I'm a Dvorak typist, and things are even more weird for the Commodore 64. So if we search from 4000 to 4040 for C64, fingers crossed I haven't tested this, it'll find it at 4010. There you go. The next thing that we've got is registers. We can display our registers, but more importantly, we can edit our registers. And we can display them individually. Without changing them if we don't provide a value. Invalid inputs like G0 immediately throw an error. The debug go command works also. Side note, my absolute favorite command ever in the world comes from MS-DOS. I should add it as like an Easter egg or something. It was G equals C800:5. That was the low-level format for MFM hard drives. It's a tiny bit different. I need to like make some modifications here. For example, it doesn't use the equal sign, but that's such a special case. It'll change the parser. So I'm a little skeptical. So if we add 4000, so we add 60 there, that is the RTS. So if we go to 4000, it's just going to return to the prompt. I know that's not super interesting, but if I jump much, well, I'm not sure if this will work. Beginning of debug, restart it. Side note, debug is resident because it's the last program that was loaded, so I can just jump back into it. If I ran any other external program, that would be the one that was run. So if I ran label, for example, it would try to run label again. And right now there's no way to pass parameters into a run from Command 64. So label would always return an error right now because its interactive features haven't been implemented. And we're getting really, that's pretty much it. We're down to version and help. I lied. What we're really at now is file IO. So files are manipulated using the N, L, and W. If we create a test program, we can then make sure that it is there and named. There's no way really to clear a test name, I don't think. No. handles trailing spaces and case sensitivity. So I can do that just the same. Trailing space is kind of impossible to really if it has trailing parameters, they're just quietly ignored. If it has too long a name, it'll throw an error, but again, that's typing out something big. So let's write out into test PRG from, we will write out 2000 to 2010, 2010, 10. We'll do another one where we fill. We'll leave 4000 now because we don't want to fill in debug. Oops. We'll fill with AAs, then write out 4000 to temp. Now, I don't recall debug in MS-DOS having much verification and validation about having actually done things sometimes. So we don't have that here either. We can go take a look on 8 to see that things have been created. I could type them out, but they would make a hot mess because they're binary. So I'm just not going to do that. I'll do that in a moment though, because I can also save as sequentials. I'll even leave off because the that extension isn't really needed. Obviously, it's actually being included, and the file type and the file extension are not technically related. So if I do test2 for my name, and then let's edit 4000 and edit 4000 and dump out 4000. See, hello Commodore 64. Where's that go out to? Is that 4011? Yeah. If we write sequential 4000 to 4011, oh my. Oh my. We'll see if this finishes. There's no real protection for this mistake. It is going to write out yeah. Well, it did, so let's take a look. See what that looks like. Yeah, test 2 is absolutely enormous. But let's go do that the way it was intended to be. Write out 4,000. And then it's already sequential, so it wrote it out as sequential, I think, should have. Might not have. Might now be misrepresented. Find out in a second. Okay. That is a bug. Let's well, that was unexpected. That might be because I didn't specify the type, so we'll try it again in a second. It is also possible it is not limiting to those, and it is writing out the rest of that 8-byte block. Let's find out together. Let's do test 3. We'll fill in 4,000 to 4,040 with zeros. Then edit 4,000. Dump 4,000 back out. Then, oh, that's very convenient. Write 4,000 to sequential 4,000. There it is, test 3. Fingers crossed. There you go. User works pretty much exactly the same way. Now that we have that, we can dump out 4,000 again. Then fill 4,000 to 4,040 with zeros. Dump it out again. Then load sequential 4,000. And there we go. Right back into where it belongs. Let's try it. Let's try it. If I set a name to DEBUG 2, let's try writing out from 2,000 to 4,000. That should include all of the debug program and probably some extra. We're so spoiled by M.2s. Now let's fill in 4,000 again. Now let's load that as a PRG into 4,000. Fingers crossed, guys. Seriously, fingers crossed. I legitimately don't know if I'm going to overwrite parts of the OS. That's looking promising. And let's see how well we did. I honestly, I do not know. That is a bit unexpected. And I legitimately don't have an answer for why. I'm going to have to investigate that, because I bet if we jump to 4,000, it does successfully run it. But it may be jumping back into the 2000s. There's some work to be done there for doing dynamic relocation. That's phase 7, I think, offhand. Yeah, I think so. It might be phase 6C, maybe. I'm not positive. And that I think kind of wraps things more or less up for file manipulation. It's got an unassemble. We can take a look at the beginning of the debug. Can specify ranges. Let's get all kinds of crazy. Dump out the whole shoot and match. You see the invalid opcodes, which of course shouldn't really be here, because this is debug basically. Maybe as we get into the tail end. Interestingly, 3000 happens to be the command input buffer, which, well, it was the command input buffer a couple of builds ago, at least. I think it probably still is. we can verify that pretty soon. If we dump 3000, I'm at 20. Yeah, there it is, right there, starting at 3001. So if we disassemble 3000, or 300 works, the question marks indicate invalid outcomes. And that legitimately is it, because the assembler and tracing and breakpoints are for later stages. Tracing and breakpoints I'm really worried about. The assembler I think is going to be complicated to a certain degree, but tracing and breakpoints, that involves interrupt hijacking, and I honestly don't know how that's going to go. I've had some trouble with it in the past, and that's why I keep deferring tracing and breakpoints. So there you go. That is debug for Command 64. If you've made it to the end of this surprisingly long video, I thank you very much. And please have a wonderful day. Thanks very much. Cheers.